Since the introduction of tanks, military worldwide have looked for methods to combat them. Since the beginning of using huge caliber rifles to heavy bombardments of artillery, countries have developed a wide range of ways to destroy tanks. Hello and welcome to Z. Please don't forget to subscribe. Using mines, airstrikes, and artillery, and even other tanks, are all viable choices. They do have their own advantages and disadvantages. Having artillery and aircraft supporting fire wonderful, but these choices are not always available. Alternatively, there might be problems with the weather or telecommunication issues their position. Mines function effectively, but there is no assurance. It will either be hit by an armored vehicle or be blown out following the explosion. When tanks are accessible, they're excellent, but on the contemporary battlefield, tanks are an increasingly unusual sight. They must also speak with the infantry. Where an adversary is, therefore costing an essential a window of opportunity for the adversary to flee. So what should a soldier do when they require rapid and precise shooting on a target with armor? The answer that the majority of military worldwide the globe has embraced man-portable anti-tank weapons. Missile. Although the system's direction varies substantially, the fundamental assumption is that each soldier is capable of using a precise and a portable, deadly weapon that can eradicating or neutralizing all armored threats on the field of combat. Although it seems like a simple idea, it has actually decades were spent developing the armament system into the equipment that military now use. In the end, creating a weapon system sufficient to destroy a tank that might be mounted or easily carried by one soldier on a little car is quite challenging. Engineering idea. The first anti-tank weapons were developed in the forefront were missiles or rockets. During World War II, almost every nation created its own anti-tank weapon. It would serve as the standard for upcoming systems. The German Panzerschreck, the British PIAT, and the notorious U.S. bazooka, to name a few instances of these. Despite being very powerful up close, these weapons have flaws of their own, from reloading challenges to accuracy issues. But in spite of their radically dissimilar designs, these early weapons all share one feature. Their explosive warheads shared was. Every weapon included is readily accessible to the general populace. Known as shaped charges technology. The use of shaped charges in anti-tank warfare due to their significantly better penetration and combat superior force to a typical high explosive bullet. A shaped charge functions in such a way that the warhead's end is explosive and has a hollow in the shape of a cone before it. The detonator is located at the end of this hollow. The detonator activates when the warhead impacts the target. Will blow up first in the explosion. Consequently, a little electrical spark is produced. That is the spark for the charge that the warhead is equipped with an explosive charge to explode. The moment the explosive charge explodes, the flows of gases from the large area of the cone-shaped cavity all the way to the pointy end, close to the detonator's location. Typically composed of metal, the gases smash the cone, creating a white-hot metal beam from copper and power. The stream refers to this action in the procedure. And there is this very hot stream. It provides anti-tank rockets with their armor-piercing ability, and it all depends on elementary physics. Consider the scenario of a 100-pound force being applied onto an inch square. There would be 100 pounds of pressure as a result. Every inch square. The example square inch would be the warhead's diameter. Let's now reduce this by developing lower the surface area and create a shaped charge whose surface the explosive charge is spread. Let's simplify things and reduce the surface to 0.5 square inches, divide the area. There would be 200 pounds of pressure as a result. Every inch square. Consequently, by concentrating the explosive energy, you can pack more into a smaller space to make it a little amount of surface area and give its capacity to cut through dense layers and armor. This mechanism can be observed when viewing images of automobiles with a high-energy anti-tank or heat attack rounds. The entrance hole is little, and the exit hole is enormous. Considering the focused energy pierces the armor with a blow, expanding once. It enters the car's interior air cavity. This fundamental idea is what makes anti-tank missiles rounds so powerful. However, there are several factors to take into gunners and engineers must think about create a potent weapon. When a shaped charge explodes too near the objective, the stream is insufficient a sufficient amount of time or room to mature, making it wasn't as strong as it may have been. If it explodes too much, as some typical rounds of countermeasures are made, then the stream will experience energy loss en route to the and are less able to breach its defenses. Consequently, shaped charge explosives must detonate at just the appropriate range for maximum impact at piercing armor with a punch. Following the conclusion of World War II, the different global powers began putting together their own man-portable anti-tank missiles. Among the first two most typical cases, there were the M72 Law, pronounced Law, an American, and the RPG-7 from Russia. Small and light, the M72 light anti-armor weapon as well as a reusable anti-tank rocket be fired without difficulty in any setting. The Law operated in such a way that whenever the trigger was pulled, a little black powder in the back of a launcher this would cause the rocket fuel to ignite and exit the tube with the missile. Simple fins would emerge from the tube once it was out. Deployed to maintain the rocket's flying stability. Russian rocket-propelled grenades are effective in a comparable manner. Despite the fact that the Russians created numerous among RPGs, the one that gained the greatest popularity well-known and continues in widespread usage today the RPG-7 is. The gunner must first screw in the RPG-7 before firing. The grenade's rear with the rocket booster. The firing pin is put into the tube. Ignites the by producing an electrical shock propellant and extinguishes it. After leaving the barrel, its fins will spread out, and the rocket booster will fire to accelerate reach its intended recipient. Despite the fact that the green heat warheads are the most well-known, can fire this weapon with more warhead types. While testing both of these weapon systems and accurate, participating in several wars from Vietnam has, and continues to have, a significant negative of being unguided. If the target is hit after the gunner fires the weapon, if the target shifts before contact, the bullet might miss. While in the near term, this might not be a concern ranges, given that the RPG may traverse hundreds of yards contrast to what Hollywood portrays, a feet per second may lead you to assume, efficient firing on targets more than a few hundred yards away becomes a problem. The United States created one to address that issue. Of the most well-known and ongoing anti-tank weapons current systems, the TOW missile. Tube-launched, optically tracked, and wireless a rocket guided by wire. Each component explains in detail what it accomplishes. The tube from which the missile is fired can, once launched, be reloaded with more missiles. The launcher has more sophisticated optics and sighting devices, such as for night, that differ greatly from the simple RPGs, and LAWs have iron sights. But this situation's most crucial aspect is its system using a wire. It's nothing to connect wires to an explosion. New. Since most torpedoes were used in both World War systems that were wire-guided. However, discarding this technology and onto land was a groundbreaking idea. By connecting the missile with a long, thin wire, it would now be able to develop a significantly more precise weapon. The method a TOW missile operates is that following once it exits the tube, it emits an infrared beacon that the missile detects system of guidance. The MGS then adjusts its path in a way that are transmitted to the missile across the cables. The missile can then follow the necessary trajectory. The target needs to be adjusted. The missile may redirect itself, so all the gunner needs to do is maintain their sights on its mark. By maintaining focus on the target, the MGS will have a consistent baseline to work from, which to communicate with the missile and maintain that is on point. This idea was very different from past ones. Russian ideas, such as the Sagar missile, required the gunner to steer manually the whole time was a missile. Given that the TOW missile system includes a feedback loop, the gunner need only pay attention on the location of the target as well as the missile. The fact that the gunner fires is an additional bonus, not needing to consider any considerations like elevation or windage. The TOW system is essentially a fundamental idea, and the shot idea. Despite the significant advancements achieved in portable, the TOW missile, an anti-tank missile, still has drawbacks. One need is that the gunner always be exposed the missile's entire flight path, since if they lose focus on the goal, the trajectory of the missile can change. Moreover, the rocket can only strike what gunner is able to see. Thank you for watching, and please subscribe.